Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एवं मु प्लस थ्री CBCS फिजिक्स ऑनर्स जीई और MSc फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक कर देबा और चैनल को सब्सक्राइब कर देबो यू कैन शेयर इट विथ योर फ्रेंड्स आल्सो इट्स कंप्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन पई बेल आइकन को एठी ऑल रे सेट कर देबो तापरे वीडियोज रो क्लैरिटी बढ़ावा पई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पाई पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज टॉपिक रे हमें इफेक्ट ऑफ टेम्परेचर ऑन फर्मी डिराक डिस्ट्रीब्यूशन फंक्शन ए विषय पढ़िबा. So before that, we have to know what is the Fermi level and what is the Fermi energy. Look, it will be seen that as the value of temperature T decreases, the energy of the electrons goes on decreasing. But जदि आमे 0 Kelvin by absolute 0 को पहुंची जिबा, then the energy of electron is not equal to 0. Moreover, as per the Pauli exclusion principle, आमे जानिचु जे जे कोनोसी गोटे एनर्जी लेवल रे एटलिस्ट गोटे इलेक्ट्रॉन तो रही परिबो. One electron can be occupied in one energy level. Therefore, there will be one electron in the ground state having zero energy. Okay, so if we say that small n is the total number of electrons at 0 Kelvin, then total number of energy states which will be occupied will also be small n, right? So each state with one electron will be there. Okay, so प्रत्येक स्टेट रे केवल गोटे इलेक्ट्रॉन ही रहिबो. सपोज आमे कहला कैपिटल EF be the energy of the highest state occupied by the electron kete at 0 Kelvin by absolute 0 re. Then all the energy states having energy value greater than this highest energy will be empty. ओके ता ऊपर आउ किछि भी एनर्जी स्टेट रे इलेक्ट्रॉन किछि नथिबो फांका थिबो बा पूरा पूरी वैकेंट थिबो. ओके सो ऑल द एनर्जी स्टेट्स having energy value less than EF will be fully occupied with one electron. Okay, so आमे एबे डेफिनेशन को आसीगला. Thus the energy value up to which all the energy states are completely filled by the electrons, remember at absolute 0, that is 0 Kelvin of temperature, and above which all the energy states are completely empty, is known as the Fermi energy, right? And it is denoted by EF. Now let us come to the topic how the temperature is giving some effect to the Fermi Dirac distribution function. First of all, आमे Fermi Dirac distribution को conveniently लिखिबा Fe, which is equal to Ne by Ge, so that it is equal to 1 by e to the power alpha plus e by kt plus 1, or 1 by e to the power e minus ef by kt plus 1. Okay, so एठी आमे alpha को लिखि परिबा in terms of chemical potential, that is mu, so that alpha is equal to minus mu by kt, right? And it is equal to minus ef by kt, and here ef is depending upon the temperature. Okay, and it is nothing but the Fermi energy at temperature T. Okay, so at temperature 0 Kelvin आमे जदि T जगह रे 0 पुट करिबा ताले एबे एटी डिनोमिनेटर रे एई जगह रे आमे 0 पुट कर देले कोन हबो जदि E minus EF पॉजिटिव आउची बा नेगेटिव आउची एटा डिसाइड करिवो. एबे एमती जदि आमे देखिबा E is less than EF0 ताले FE रो वैल्यू हे जिवो केते 1. ओके, जदि E टा EF रु छोटो अछि ताले FE रो वैल्यू 1 आसीबो, राइट? आउ जदि E is greater than EF0, then the value of FE will be 0. Okay, so this is shown in the figure. But before going to that figure, याको एबे मैथमेटिकल टिके हमें बुझी देले भी बेटर हबो. देखो फर्स्ट कहूची E is लेस देन EF0 माने एई जो एक्सपोनेंशियल रे थिबा एई क्वांटिटीटा आमे देखिया को पाइबा जे एटा नेगेटिव आछी ओके नेगेटिव आसिला सपोज e टू द पावर माइनस ऑफ सम नेगेटिव क्वांटिटी लेट अस से a ओके a डिवाइडेड बाय kt अछि t रो वैल्यू तो ऑलरेडी आमे 0 पके सारछु सो माइनस a बाय 0 okay or it is simply is equal to e to the power minus infinity. What is its value? 0. Okay, so 1 by e to the power minus infinity plus 1 or 1 by 0 plus 1 so that यार value आसीगला 1 second टाको एबे देखिबा when e is greater than ef0 এটা যদি আসছি তাহলে এবে কোন হবো এই যে এক্সপোনেনশিয়াল র পাওয়ারটা পজিটিভ হয়ে যাব সো e to the power plus a by 0 or it is equal to e to the power infinity. It is nothing but equal to infinity. So 1 by infinity plus 1 or simply 1 by infinity which is 0. ओके सो एबे बुझीगला ताले एबे आसीबा हमें फिगर को जो थिरे कि एबे ये यार वेरिएशन देखौची वेयर y एक्सिस रे ये नै गला फर्मी डिराक डिस्ट्रीब्यूशन फंक्शन आउ एनर्जी को नै गला x एक्सिस रे ताले 0 रु 1 भितरे यार रेंज ता रहूची ओके राइट आउ जो जगह रे एठी मिसुची एनर्जी एक्सिस सहित दिस इज EF0 ओके अच्छा एबे आमे जदि देखिबा the variation is shown by the solid line okay या तो 1 आसुची यार वैल्यू किमा डायरेक्ट या आसी जाउची 0 को okay at any temperature किंतु एटार मन रखो ए solid line टा होउची at t equal to 0 kelvin okay absolute 0 रे however at any temperature t माने non zero temperature fe रो value it is equal to 1 by 2 for e equal to ef okay this fe is equal to 1 by 2 for e equal to ef যদি এটি e জায়গায় ef পুট করে দেলে obviously এই এক্সপোনেনশিয়ালটা র পাওয়ারটা 0 হয়ে যাব e to the power 0 is 1 so 1 by 1 plus 1 give you 1 by 2 right so the value of ef is determined by the condition that total number of particles is constant at a given temperature t right acha now back को बढ़िबा the expression for the number of fermions with energy between E and E plus dE yaku lekhiba for the case of your free electrons in a metal okay yaku ame lekhi pariba NEDE equal to FE into GEDE okay previous class रे यार expression ame pai thila already taku put kar dela right tale at absolute zero all the states with your 0 less than e less than equal to ef0 are completely filled jota hame already definition re dekhila and all the states above are empty so the value ef0 that is the ef value at t equal to 0 kelvin is determined by taking the number total number n equal to 0 to infinity of NEDE यार value put कर देला okay ताले आमे ऑलरेडी ऊपर देखिला एफ ई रो वैल्यू 1 आसीबो बा 0 आसीबो सो 0 आसीले तो किछि भी एठी आमे वैल्यू पकी किछि लाभो नाही 1 ही पुट करिबा एफ ई जगह रे ओके माने एटा रेंज एबे आसीगला 0 टू अपर रेंज टा लिमिट टा आसीगला ई एफ 0 ओके आउ ई एफ 0 रु जदी एनर्जी बढ़ुची ताले हमें देखुतला एफ ई रो वैल्यू 0 आस्तला ओके ताले एबे जी ई डी ई रो वैल्यू पुट करिबा okay after putting we try to solve it okay so solve जदि आमे करिबा को चेष्टा करिबा by using this limit finally amara value आसीबो this much 2 by 3 ef0 to the power 3 by 2 बाकी सब constant quantity already बाहरे अछि ताले ef0 रो value आसीगला this much which is equal to mu f and this represents the energy of the highest occupied energy level at t equal to 0 Kelvin and it is known as the Fermi energy. Okay, so for the particles of spin half because we know that fermions are actually the particles of half integral spin so These are some maybe examples like electrons, protons, also neutrons. So the spin degeneracy factor GS will be equal to 2 into S plus 1, that is 2 into half plus 1, or that is your 2. Okay, 2 into half plus 1. Okay, formula GS ର କେତେ ନା 2S plus 1. This is the value of GS. So ଏଠି finally यार value ଆସିଲା 2. So this means that each level can be occupied by two particles, one with spin up and the other with spin down. Okay, याको up down arrow रे हमें mark कर देला. So suppose rho ही गला, if rho is the density of gas given by mn by v kg per meter cube, then numerically EF0 equal to mu f is equal to यार numerical value टा ये लिखुची 0.625 into 10 to the power minus 27 rho to the power 2 by 3 joules, or 39 rho to the power 2 by 3 electron volt per electrons. A proton ପାଇଁ यार value ହେଲା 0.227 into 10 to the power minus 20 rho to the power 2 by 3 joules, or 1.42 rho to the power 2 by 3 electron volt in case of your protons. Now for conduction electrons in metals, rho is nearly equal to 0.1 kg per meter cube. Okay, these are some of the numerical values. Okay, now the Fermi-Dirac gas possesses appreciable energy at absolute zero, while in case of your Bose-Einstein and classical statistics, that is your Maxwell-Boltzmann statistics, they predict zero value of energy at 0 Kelvin. Okay, এটা হচ্ছে the difference. Okay, so this is because why that Ni can have 0 or 1 only in case of your Fermi-Dirac statistics. Okay, Ni ର value 0 କିମ୍ବା 1 ହିଁ ହେଇପାରିବ. Now as the temperature increases above 4 Kelvin, the Fermi-Dirac distribution function near EF0 takes the shape of the dotted line. Okay, जोटा हमें ऊपरे फिगर रे देखुतला जेतेबेले टेम्परेचर बढ़ुची देखो ए हिसाब रे Fermi-Dirac distribution रो shape टा dotted line हिसाब रे चेंज आउछि. Okay, ताले this is the case of your temperature greater than 0 Kelvin, which is around 4 Kelvin, right? So let us now define a temperature Tf, which is called as the Fermi temperature, so that it is given by EF0 by K. Okay, or you can say EF0 is equal to KTF. So it is equal to mu f by K. ହେଲା ताले एबे यार value हमें put कर देला जो ऊपर पाई थिला, right? So in terms of your density एतिकी हमें लिखि परिबा, right? Now when this temperature is very less than Tf, so that KT is very less than EF0 or KTF, then the distribution is called strongly degenerate. A degeneracy विषय रे हमें आपको detail पढ़िबा upcoming classes रे. So when the temperature T is greater than Tf or KT is greater than EF0, then the distribution is called slightly, or better to say weakly degenerate. And when this temperature T is very greater than Tf or KT is very greater than EF0, then we get the classical limit, or the distribution becomes non-degenerate. That is in case of your Maxwell-Boltzmann statistics. So here the value of alpha is negative in case of your strongly degenerate system, while it is positive for the non-degenerate and slightly degenerate system. Okay, and due to equation 16 ऊपर जो देखिला, this means that EF is greater than 0 at low temperature and EF is less than 0 at high temperature. Okay, so ଏବେ ଆଉ ଟିକେ ଯଦି ଆମେ further discussion କରିବା ତାले physical interpretation of Fermi energy at absolute zero is that it represents, as I said, the highest energy level at T equal to 0 Kelvin in which all the quantum states are occupied. Okay, and ऊपरे जो equation declared that shows that absolute zero temperature रे the function Fe is constant and it is equal to 1 for all the values of energy up to EF0. Okay, এটা ଆଉ ଗୋଟେ ବହିରୁ ମୁଁ ଯେହେତୁ edit କରିକି ନେଇଛି. Okay, same as EF0, and at EF0 it suddenly falls to 0, right? So at absolute 0 temperature, Fe is said to be a step function. Okay, as you can see in this figure. आउ जो अलगा अलगा टेम्परेचर रे जदि आमे देखिबा फॉर हाई टेम्परेचर देख एबे एठी शेपटा केमती चेंज होउची. ओके, आउ जदि टेम्परेचर बढ़ाई देबा शेप आउरी एमती चेंज आसीबो. ओके, सो एटा जो तीनटा फिगर तुम देखा पाच. द फर्स्ट फिगर इज एट 0 केल्विन फॉर ऑल लेवल्स एबव Fe आर अनअक्युपाइड. आउ सेकेंड फिगर होची फॉर ग्रेटर देन 0 केल्विन some particles near Fermi energy level here they can move to the level above EF. बाकी जदि बहुत हाई टेम्परेचर नहीं बा देन पार्टिकल्स इवन इन द ग्राउंड स्टेट मे मूव टू द हाईएस्ट लेवल. और यही हिसाब रे यार प्लॉटटा आसीबो. राइट, आकु बढ़िबा. So Fermi energy at T greater than 0 Kelvin, जदि आमे कहबा that is for T greater than 0 Kelvin E is equal to EF. So आमे जेमती मु कहउतली e to the power 0 हिजबो and it is equal to half. The distribution function becomes equal to half. So this gives the physical interpretation of Fermi energy at a finite temperature T greater than 0 Kelvin. Okay, thus the Fermi energy EF at T greater than 0 Kelvin is that energy in which 50% of the quantum states are occupied and 50% are empty. Okay, এটা ଗୋଟେ यार physical interpretation देला. And it can be shown that as the temperature increases, the value of EF decreases slightly, and therefore for practical purposes EF at temperature T may be considered constant and nearly equal to EF0. Right, ଏବେ ଦେଖିବା এই EF0 ର value in case of your metal. देखो total number of free electron in case of your metal ଆମେ ୟାକୁ ଲେଖି ପାରୁଥିଲା n equal to, again I am saying this is taken from another book, so ଏଠି denote जदि करिबा देखिबा जदि किछिटा चेंज ହେଇଛି एठी कैपिटल n अछि यार प्रीवियस बुक रे स्मॉल n थिला. ओके, स्मॉल डिफरेंस आर देयर. सो 0 to infinity आसीगला इंटीग्रेशन रो लिमिट NEDE और FEGD ऑलरेडी हम एटा ऊपर देखि सारिछु. सो एठी याकू हमें दुई भाग रे भाग कर देला 0 to EFO to infinity ऑलरेडी देखिछु एटा. सो we know that at t equal to 0 Fe रो वैल्यू दुईटा आस्तला, गोटे हला 1 आ गोटे हला 0. केमती जदि एनर्जीटा EFO रु छोटो अछि बा बड़ अछि. ओके, जदि बड़ अछि ताले Fe तो 0 हो गला, किछि भी वैल्यू एठी हमर सेकंड टर्म रे रहिबो नाही. सो n रो वैल्यू फाइनली 0 to EFE की कैलकुलेशन हबो. ओके, सो यार वैल्यू accordingly एतिकी आसीबो. Okay, from which we can get the value of EFO to be equal to h square by 2m 3n by 8 pi to the power 2 by 3. Okay, here small n is equal to capital N by V, which is the number of free electrons per unit volume, that is the electron density. Right, so the value of EFO as calculated here for the number of metals are of the order of several electron volts. Okay, and this fact highlights a very important difference between the classical statistics and the Fermi-Dirac. And according to the classical one, all the electrons in a metal at absolute zero would have zero energy. Okay, same jinso ei bohi re bi kahila. Okay, so finally the average free electron energy at absolute zero. देखो Fermi energy जो एक्सप्रेशन हमें पाई थिला EF is equal to this much. ओके, ताले एबे हमें कोन करिबा ए एक्सप्रेशन जो अछि ए 2/3 फैक्टर एटा को आर सेट को नेबा हला. ताले we can get 8 root 2 pi V divided by h cube m to the power 3/2, it is equal to 3/2 n EF to the power 3/2. एबे आमे NEDE रो जो वैल्यूटा पाउथला प्रीवियसली ताकू लिखिदेला. ओके, NEDE रो वैल्यू प्रीवियसली जो पाउथला ताकू लिखिला. नाउ इक्वेशन 1 आउ 2 को यूज करिकी वी कैन राइट NEDE to be equal to एबे रिप्लेसमेंट आनिबा. ओके, दिस इज रिमेनिंग सेम. एई जगह रे हमें रिप्लेसमेंट आनी पकेला. एबे एब्सोल्यूट 0 रे देखिबा ताले दिस एक्सपोनेंशियल will be equal to 0. So NEDE value asigala simply this much. Okay, Then if E0 be the total energy of the electron gas at absolute zero, then E0 is equal to 0 to EF E NEDE DE0, and substituting the value of NEDE from above equation जोटा equation 4 थिला ताको एबे जदी पुट करिबा ताले एबे टोटल एनर्जी आसीगला याकू जदी हम फर्दर कैलकुलेशन करिबा इंटीग्रेट करिकि ताले 0 to EF ही आसीबा हमर लिमिट टा, and finally its value will be 3/5 NEF. Okay, this is the final expression. So the average free electron energy at absolute zero is given by, now E0 bar, as you are saying average, so E0 bar, which is E0 by capital N, so that it is equal to 3/5 of EF. Okay, so this is all about the effect of temperature on the Fermi Dirac distribution function.
Thank you.